Alright, so I already uploaded everything about this stuff in the last this year and last year on another YouTube channel, an actual YouTube channel that I'm doing for educational purposes. But I decided, since this is also just part of my person, my stuff that I'm doing, I decided to do a similar video for my favorite two projects I worked on. This project is what I worked on last year. This project is what I worked on this year. Both of these I've done within a day, of course. I'm not trying to make it sound like a year-long project or anything. But, so, I guess where do I begin? So there's two different programs here. This program up at the top that I'm going to show first is this year's project. It has to do with being able to calculate distances between two places on Earth. Basically, just kind of like the distance feature in Google Maps, except this is much easier to use, and you can also use it. This is mainly for use with a desktop PC. The bottom of which is my favorite cipher. It's a very old cipher and was unbreakable for about 1,000 years, called the Vignear Cipher. And so this is a computer program script to do just that. Because of the nature of my screen recording, I'll show the application of these in a separate video. This video is just for explaining the code. So in this year's project, I made the distance calculator. First of all, I guess to start off, there's different parts. There's the there's the definitions, and then there's the other parts of the script. And so definitions, I usually start with first. There's two main definitions to understand for the script. Is how to calculate and how to clear the board. Pretty simple stuff. This means that it just gets rid of all the information because of subtraction. That's all you have to know, is that it subtracts all the values. In other words, 5 minus 5 is 0, 4 minus 4 is 0, 3 minus 3 is 0, blah, blah, blah. You take the value and subtract itself, it's out. The identity, which we take for granted. I am actually in a math major, and we learn in abstract algebra all kinds of other arithmetics where simply subtracting a number from itself doesn't always equal 0 in different arithmetics. So it's easy to take that for granted here, and it's useful here, but that's not always true in every single arithmetic. Sometimes you can subtract an identity, and it's not the additive identity. Anyway, so then here's the definition of calculation. Basically, we take the sines and cosines of everything times the radius of the Earth, and that means we're locked to the spherical origin of the Earth. There it is. So that's more clear. That's the radius. And so we're tied to the spherical surface of the Earth. So all distances here have to go through the spherical surface rather than a direct straight line to another position. Alright, so this is going to make a pop-up window. It's going to be called Distance Calculator. And this is going to be the relative size when it comes up. And this is what it's going to do. You can input different numbers here, and it's going to pop out a particular number in kilometers. Sorry, but kilometers is just what we got to work with here. You can also clear everything, and you can calculate. So these are the two buttons you can press: clear and calculate, which is defined by our definitions up here. So you can put in the location. So what you do is you go to Google Maps and you just type in any destination you want or any location you want, two locations, and in the URL of those locations will include the actual GPS coordinates of those places. So we list those as X and Y into our box. And since we list them as X and Y into our box, X1, Y1, X2, Y2, we can get, through this formula, the distance between them. And so it's a window.main loop, so you can keep using this over and over. Now, the other thing, let's go ahead and denature this. So this one I made last year. It's about the Vigonier Cipher. For those who don't know, the Vigonier Cipher is a way of sending in secret messages. That's like it's the evolved form. If you think of Pokemon, it's the evolved form of the Caesar cipher. The Caesar cipher is a shift cipher that changes the letters of the alphabet to another shifting of the letters of the alphabet. In other words, you can have Z is equal to A, B is equal to Y. Well, let me just type it for you. So Then normally in the letters of the alphabet we go A, B, C, D, E, F, G, right? Well, let's just say that's the only letters of the alphabet. Then I can pair them like this. I can say, oh, okay, well, there's G, F, E, D will pair to itself, C, B, A. And so I can pair these with each other like that, or any way I want to. As long as there's a one-to-one, mathematically we would call it bijective. As long as there's a bijective relationship between the two letters, then we can do our secret code cipher with a shift cipher. For those who are unfamiliar, bijective means it's injective and surjective. Injective means that there's one and only one way to go from A to B, or in our last situation, from A to G. And that there's only one and only one way to go from G to A. That's the mathematics behind it. That's surjective. So in this case it would be injective, and this would be surjective. And if you have both those conditions, then we just put bi, as in it's two, bijective. Alright, so we have a bijective function here because these terms map only to each other. They don't map to anything else. Not all functions should be or need to be this way. In fact, some of them can be injective only, as in G may map to A or B. So you can't exactly identify which one it goes to. Well, in this case, this would just be injective only. Well, I guess it's also the reference point of what counts as your starting point. So I guess I should have done this. A can map to G or I. So in this case, it'd be injective, but not surjective. And I got it backwards. Sometimes I get confused between these terms myself. So yeah, basically that's the point. Inject means you can put into, like an injection. You can put into. Surject means you can come back. So if you think of it like a destination and coming back, it's like injective means you're going to one and only one place. Whereas surjective means you can come back to one and only one place. So I guess better to say like this is an example of something that could be injective. But it's not surjective because G then maps to A and B, and that's confusing. So it's injective, but not surjective. So anyway, that's kind of the basic mathematics behind it. So in a secret code cipher, you need everything to map, because you want to encrypt something and then decrypt. You need someone later to come back and find out what you said. So you need it to be bijective. So that's the basic, mathematics behind this. So anyway, with this program, let's start with the definitions. I have generate key, which means to generate the key for this particular cipher, which I'll get into in a moment. Cipher text and encryption text. So these are ways of encrypting and decrypting the code. So if you wanted to say, I like Reese's Puffs cereal, well then you need a key to encrypt it. So the key could be balls. So that means every single letter gets scrambled by one letter of the word balls. So these correspond like so. And just keeps going like that. Now it needs to find out, this program's going to have to find out, well, how many letters are in my code here? And so it's going to repeat balls over and over again. Maybe I should say puff, since it's a puff. Well, then you don't want the same words. If puff's in the thing, you kind of don't want the key to be the same, so we'll just use balls. 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 Alright, so you have a lot of balls right here. And I don't know if that's the exact amount, but it's going to repeat over and over again. So let me just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, B-A-L-L-S. You have 5. So 1, 2, 3, 4, ball. So that's the key that it will generate, which is what this code here does, is that it takes all of this, puts it together into one word, so it joins all the spaces together, Then it capitalizes everything, but that's another story. And then it just, oh yeah, see, then it pairs it with balls, just like this. So now we have a nice even pairing, and it scrambles it according to this. And then maybe this is our result. I'm just making something up here. And then if you wanted to decrypt it, it'll take this message, use the encryption key, and you'll get back, I like Reese's Puff cereal. So it's a bijective relationship. You can go forwards and you can go backwards. Whereas if it wasn't bijective, there could be the case where you can go forwards but not backwards, or you can go backwards but not forwards. And since this is chronological, then surjective really doesn't make much sense anyway. Anyway, so you got that situation. Oh, this is not... Why is this in here? It's not supposed to be that kind of file. Yeah, I was trying to make this a pop-up window too, but I haven't really started on that. So that's how the definitions work. Now this is while true, which means this is constantly going to be happening unless if you hit the break command. The break command is quit. So it's like, do you want to encrypt or decrypt? And it does its thing. If you at any time you hit quit, then it's going to stop everything. So assuming you don't do that, it's going to continuously run through this script. This script will ask you for, if you decide to encrypt, it's going to say, okay, well, give us the encryption script, and give us the key, and then it's going to give you your answer. Of course, it's going to prompt you to quit if you want to, or you can keep going. Then you can do decrypt, give us the coded message, give us the key, and here is your decrypted message. And if anything weird happens, which I don't anticipate, but it's always good to have this kind of command, it'll just say, sorry, something weird happened, please try again. Again, all steps of the way, you can type quit to quit. And that's why it continues here, because it's just going to constantly go through this loop, unless if you hit the break command or something weird happens. So this thing will not take punctuation, and will not take words and letters. It just can't encrypt those things given the way it's structured. There's a more in full detail of this particular code in the video I have on my other YouTube channel for educational purposes. But yeah, I just thought these were pretty cool. So I'll upload another following video about actually using these things in the field. It's pretty cool.